Good morning, kiddos. Today we're going to be talking about the introduction to Pythagorean theorem. As always, please feel free to pause, stop, rewind, do whatever you need to do to follow along with this lesson and make sure you understand, okay? Also, don't forget office hours and small groups are always available to you, all right? Let's get started. So, how is the Pythagorean theorem used in everyday life? So, this access ramp, you've seen access ramps like usually with they're usually made for handicapped people so they can wheel their wheelchair up or skateboarding. That's things we use in everyday life to create, to use Pythagorean theorem. We use Pythagorean theorem to create those things, right? So the access room will be covered with an all-weather carpet. Would you be able to find the area of the carpet needed? That's what you use Pythagorean theorem for. So the Pythagorean theorem formula is a squared plus b squared equals c squared. That will be your formula. This formula will be on your formula chart, but I will advise you to memorize this formula so you know how to work it front and back, okay? Using this formula is just going to be just like other equations that we do. When we get there, I'll explain it more, but everything we do on one side, we're going to do to the other, and we're going to do opposites. So if it's multiply, we're going to divide. If it's divide, we're going to multiply. If it's squaring, we're going to square root. If it's square root, we're going to square, okay? So back to this at hand. It is used when you are finding the missing sides of a right triangle. Please note right triangle. We're only using the Pythagorean theorem when it comes to right triangles, okay? Not any other type of triangle, but a right one. So who came up with this theorem? Pythagoras was a teacher and a philosopher. Pythagoras lived during the 6th century BC on the islands of Samos. What does the theorem mean? Pythagoras found out that for a right triangle, the square of the hypotenuse is equal to the sum of the sides of the other two sides. A and B are legs. So this is A and this is B, and they are going to be called legs. Simple as that, legs. While this is C right here, and this is going to be called your hypotenuse. You'll know that this is your hypotenuse no matter how it's shaped, like no matter if the triangle is flipped around or what, you'll know because one, this is always going to be your longest side, meaning this number C should always be bigger than A and B. Also, it's opposite of your right angle. So here's your right angle right here, and it's going to be opposite that. So those are the two ways you know that this is that C is your hypotenuse, and the other two is A and B, okay? Now, getting into this, A and B can be whatever number, right? We could say that this is A and this is B, or this is B and this is A, however, whatever. It doesn't matter, we can change them. But C will always remain C. It will always have to be the largest number. It cannot change. A and B can be changed out, but C cannot. So, the green squares area, which with area C squared, equals the sum of A and B. So if I took A right here, this square, and added this square, it should evenly fit into this square right here. And that's the whole theory of it all, okay? So if I add this yellow square plus this blue square, you would get this green square. Just like in art. Isn't yellow plus blue, don't you get green, right? Okay. So let's look at it. Use the Pythagorean theorem to solve this problem. The shaded surface of this access ramp will be covered with all-weather carpet. Find the area of the carpet needed. Draw out the triangular prism on your paper and solve. So honestly, it's giving you a lot of information. All it wants to know is this side right here, right? This side is congruent to this side right here. So if this side is congruent to this side, we know that this should be our C, right? So we are solving for this. Again, A squared plus B squared equals C squared. And right now we're going to stop right here and solve the problem in part 2, okay?